So that brings us to swales. Swales are design systems that turn erosive runoff water into soil infiltrated water. So that's the definition from the designer's manual. And I want one key thing to you guys to think. It says erosive runoff, meaning that if water is not running over the landscape and it causing erosion, the swale's not really going to do anything. Okay? It means that if you are standing in your yard and it's raining and water's running by your feet and it's slightly brown-ish, it's carrying solids, right? That's a good place to think about slowing it down with your berm, speed bump, spreading it out and sinking it in. But basically, if I'm standing in a big rainfall event and it's raining and there's even water, I'm standing in a little bit of water, but it's not moving, it's not going anywhere, it soaks into the ground. Well, if it soaks into the ground, it soaks into the ground. What difference does it make if I make a berm? It's not going to stop it from moving, right? And I can dig a ditch and the ditch fills up, but why do you want a ditch to fill up when it doesn't make any sense? So we need, and typically we're going to find these on slope, not on flat surfaces. It might be more appropriate for you to just dig a small pond if you want to do some type of earthworks on a flat surface to store water, like a koi pond or something like this. Or think about, hey, make a natural swimming pool. That's another great way to store water in case you need it. So what are these described as? Long, level excavations or channels along a contour line. So we're going to have to look at how to find contour. So we're going to look at, on our morning practical, I'll show you survey equipment, string lines, how we can find contour in our landscape so that we know where to put these. But what we're doing is just finding the contour line or a level line. They intercept or slow overland water flow. So if the water's not flowing over land, there's nothing to intercept. It's like putting up a speed bump and there's no cars. Doesn't really make any sense. So help water infiltrate and it will recharge our groundwater. And if you have a pond, if I catch, like we do here at Raktamachat, I have the mainstay swales that go up the property on our contour. They infiltrate water that eventually percolates under to recharge our ponds as we use the pond water for our garden. And they normally are accompanied by tree planting, but not all the time. In some instances, because of shade or shadow, you may not actually put trees on a swale. Okay. For instance, at Bill Mullison's farm, Tagara, we'll see a picture. He does not have trees on his swales. Okay. He has some swales with trees and some swales without trees, and later we'll see why he does that. So this is the actual book that brought all this together, or the graphic from the designer's manual, figure 7.23. And I want you really, really to look at this, guys, because graphics artists, some things help us. They make things easier for us to see and appreciate. But they've really messed up this picture because almost every picture on the internet is different than this. They took the same picture and they put the tree on top of the berm. And look at this, there's no trees on top of the berm. You walk on top of the berm. The tree is at the section line. Because if you put it on top, when it's not raining, it'll be dry. You put up a berm 1 meter tall, your tree may die. So you plant it, it's a rainy season, it tries to go through the dry, it's not going to make it. It's very, very dry. So he put the tree at the intersection. So when the berm slows the water, it keeps the water there. So this is passive water harvesting. So he has the 2 trees planted basically at that dotted line, okay, not on top of the berm. But almost all the time, this has been confused. Everybody is going by these infographics that don't relate to the first graphic nor to P.A. Yeoman's book, and they're putting the trees on top of the berms. It's probably more appropriate, especially if you're in a dry place. So now if you're in a really, really rainfall event place, and you're on a flat anyway, it doesn't really make any difference, but you didn't need a berm in the first place. Right? So this is also a problem where we start to see in urban situations, call it the U.S. particularly, and suburban areas, I got to go to make my permaculture and I need to go into my yard, and if I don't make a swale through my yard, then obviously I'm not permaculturist, right? Guys, if it's not overland erosion, it's not needed. Okay? Would be more appropriate to use other systems like grasses, vetiver lines, yeah, and trees to infiltrate the water, because you'll maximize your growing area. So when you do this, you're going to limit your growing area. It's not the point unless you have erosion. So we'll come back to greywater recycling in another lecture, but Bill does go over how to utilize greywater recycling even on a city-wide center, so how we could actually use greywater systems to treat cities. We'll come to that later. But for a more appropriate, I'm just going to show this now because it does tie in with a dam, and we'll come back to it in more detail later. But there's a dam. He has water from the dam, and this is what's happening to a certain extent with the house that we saw earlier. The water from the dam fills what is called a sand filter. So that's our first stage water filter. The sand filter then has what's called upflow water filter, right? So the water goes down and the gravity pushes the water up to overflow, right? Comes into number 2, which is a rush or reed bed. In this instance, Bill is saying that this rush or freshwater reed bed, he's growing mussels. So he put mussels, right, inside of the reeds. So his reed bed has mussels, they're a filter feeder. He probably would indicate that he didn't write in the book or not, but I imagine that the owner would eat them because they're not filtering, say, bad water, just filtering the pond water. To number 3, which is the holding tank. And the holding tank has a limestone base, i.e. it's made out of concrete. That helps with the acidity of the water. Then it goes to home use. So inside of the house, it's used for whatever you want, shower, drinking, anything. The digester and or septic tank, meaning that if he flushed a toilet, so the house has a flush toilet, goes to number 5, a digester and septic tank. Afterwards, he goes to a greenhouse pond with a water hyacinth. So the reed bed, in his instance, is not a reed bed. He has a pond similar to the one I have, and if I have water hyacinth in the, the mock-up that I have of the natural swimming pool by the workout sala, or right, yoga sala, that has water hyacinth growing in it. So if I was to take the water hyacinth, I could put it into this one, but I plan to put a reed bed. So I didn't do that. But the water hyacinth would take out the nutrient, and then you can take the water hyacinth to make compost. So he has that inside of his greenhouse. Okay. Afterwards, he pumps the water to his garden. So he's actually indicating here, which is not recommended by most educational things to pump because of pathogen transfer. But Bill would believe, like I would believe, but you have to make your own risk and tolerances, right, guys? That after 3 kingdoms, there's no pathogen transfer. He's pumping the water from the greenhouse after the water hyacinth onto the garden. And then we have through flow, meaning 90% sinks down. It goes down to the subsurface or water table and it's pumped back up with the windmill back to the pond. So he's showing that in the concept of wasting water, where's the waste? If the nutrients are taken out, there's no nutrient loss. That's our mineral cycle, chemical cycle. And then the water is going back into the pond and then comes back for reuse. But we'll get into that more detail on a separate lecture.